That will be one of the smaller exit tickets, not a real big exit ticket. All right, there we go. All right, so at the bare minimum for that exit ticket, and this is gonna, so again, talk about the quizzes. Quiz grade average is maybe lower than normal even on this last quiz, which I don't understand because there was a lot of really easy stuff on there. So, and we will not have an entire quarter to bring those grades up. Remember, you test in May. Oh, raise your hand if you're in biology. 1, 2, 3, 4, just 5 is all? You people that are in biology will have less time because you're going to be pulled out of class to do your biology EOC one day. Maybe, I don't know if it's one day or it might even be 2 days. Although I guess you'd only miss one of my classes because I see you every other day anyway. So you'll miss another day. Obviously, we do our normal exit tickets that we have to do. So I'm guessing we'll miss, I might be pulled out of class because I may have to help with the geometry EOC because I teach geometry also. So don't count on like the last week or two us being able to do a bunch of exit tickets to get grades up. So when we do these next few exit tickets, you need to treat those like they were a big quiz, even if they're 25 points instead of 100 points. These 2 or 3 things, depending on if you count this as 2 separate questions, this is the easy part of the next exit. Something like this is on that level. Easy, easy, easy. So we would say, if this is the formula that we learned, well, this is the formula we learned. F of x, so this is the, for those of you that weren't here, this is the equation or the formula for an exponential function. Actually, I'm going to write it just like they write it, and then I'll explain it. So that's what it is. So write that down real quick. F of x equals AB, and then the b is raised to the x power. X is the exponent on that b. So the first thing you need to understand, and this is true for any variables, if we have an a and a b next to each other like we do here, that means a times b. 2 variables next to each other, no math in between them means you're multiplying. So that is a times b. So we have an equation here set up in that formula. Something times something that's raised to the x power. A number times a number raised to the x power. So that's exponential format only with numbers, exponential format with the variables. So in this format over there, oh yeah, I have room. Okay, there we go. So these letters are represented by, like, there's a way we find them basically. We said the b value. Oh, and I should say an exponential function is a function that is based on a pattern of multiplication. And we'll get into some examples, but if you remember when we did, so this is a linear function, not exponential linear, like that was just what the y equals mx plus b was, linear. We said we were adding the same number, like we looked at a table, we were adding the same number over and over and over, and that's the pattern. It was based on addition. Here in exponential functions, we have a pattern, but the pattern is going to be based on multiplication. So you may want to just jot that down. You'll get more information on it. But for an exponential function, the pattern is based on multiplication. Or multiplying, if you want to write based on multiplying. So for an exponential function, which is circled right there, how to spell that, the pattern, hopefully you know how to spell pattern, well, pattern's right there, is based on multiply. Linear, it's based on addition, adding the same number over and over again. Exponential, it's based on multiplying the same number over and over again. And that makes sense because we just did exponents, and what an exponent told us to do was to multiply the base times itself over and over and over again. So that makes sense that an exponential function would be based on multiplying over and over and over again. So the easy questions that we talked about in the last class were just picking out what number represents what in the formula. Now in a linear, so this is linear, by the way, up here, because there's no exponents, and we'll talk about that in a second. In a linear equation or a linear function, we said the slope or the rate of change is the pattern. Is that the door? We said that was the pattern. Here. In the exponential function, the b is actually the pattern. I don't know why they changed the value of, or not the value, but the meaning of b. Because here the b is the y-intercept, remember? Plus that. So in the other linear equation, the b was the y-intercept. Now, for some reason, they made the b the pattern. I don't know. But there's still an easy way to tell when you look at the numbers what is what. So instead of worrying about b's and a's and m's and all that stuff, here's what I think the easiest version is when you get something with numbers in it, or even if you do have the variables. The pattern is always the one that's with the x. So m was the pattern. Well, m is with the x, right? M is being multiplied here versus being raised to the exponent. Here, again, 6 is with the x, so that's the pattern. Or b is with the x, that's the pattern. So whatever is with the x, doing some kind of math using the x, that's the pattern number. So when I ask you which number is the pattern, it's the one with the x. Even if I ask you about a linear equation, which one's the pattern, it'd be the one with the x, whatever number is with the x. So the pattern number, or the b variable for this one, is 6, because that's what's with the x. So probably pretty good guess that the y-intercept is going to be the only other number in it, and it is. So the first number here, I guess I'll do it over here too. That's the y-intercept. The first number, basically the number that's not with the x, is the y-intercept. So in this case, 4 is the y-intercept. Question? I mean, your short version, the number with the x is the pattern. The number not with the x is the y-intercept. If you have an equation. Now, if we have a table, there's something else you have to do. I'll go over that next. So now from the equation, it's a little tougher on the pattern. Y-intercept's not really that much tougher. So we said, does anybody remember how to find the y-intercept from a table? I think a couple people have.
When x is 0.
You need to look at the table and find, hopefully they have it. They don't always have it, but most of the time they have had it. If you can find a row or a column or values or whatever you want to call it, where x is 0, that's where you need to look to find the y-intercept. If x is 0, whatever the y value is that goes along with that ordered pair, so that ordered pair right there is really just 0, 1, because that's the x value and that's the y value. So wherever your x value is 0, your y value is the y-intercept. So that was the y-intercept right there. We don't have to do any math. Don't have to do any math. Well, we don't have to do any math on that one. Sometimes you do. I'll show you what I'm going to do. But if you find, again, I think every table they gave you the other day on the show, I got to give a sheet to you guys that want. They gave you a value. We don't actually even use it today, but we might use it next class. They gave you a row where the x was already 0. Like you didn't have to figure out when x was 0 or how to get to 0. But you will today. I'm going to show you one that we do today, too. So again, x is 0, y is 1, and that's the y-intercept. And the reason for that is real quick. We know, hopefully you remember, the y-intercept is just where our line crosses over the y-axis, right? So those are all y-intercepts. That's where my line crosses. Well, at every single one of those points, x is 0, right? Here are my x values. Well, x is 0. It doesn't matter where I hit it, how high or low, x is always 0. The y value changes, it goes up and down, but x is always 0. So if I can find where x is 0 on the table, then that tells me what the y-intercept is. The pattern is a little tricky. Because remember, the pattern is based on multiplication. And if I look at this really quickly, I can tell, what am I multiplying times 2 to get to 4? 2, right? Simple. Easy pattern, right? 2 times 2 is 4. But did I just multiply 1 times 2 to get to 1.1? Yeah. I did. 1 times 2 is 1.1. Yeah. 2, right? It's not 1.1. So why am I not getting a pattern? Because this is an exponential function. We did it the other day. It is. But the pattern, we should have a pattern based on multiplication. I just multiplied by 2 here, but that didn't work there. Here's why. You shouldn't know this yet, but you're about to. I'm just getting, is anybody still writing anything? I'm going to get rid of all of it. Here's why. When you are determining the pattern and trying to solve for the pattern number, like what am I multiplying by, you only look at the rows or columns, depending on how your table looks. Is it going up and down or left and right? You only look at the values where x goes up by 1. 0, 1, 2, 3, 4. These in between can't be used to determine your pattern. Not in an exponential function. It actually can be used in a linear function, but not in exponential. So if I look at only these, well, now I am multiplying 1 by 2 to get to this next step. And I am multiplying 2 times 2 to get this next step. So it does work if that's the only places I'm looking. So you won't deal with that a lot, but if you ever happen to get a problem where it's they say the pattern is something like they say that it's called a constant ratio. If they say the constant ratio is a number, but you're multiplying by that number and you're not getting the same values in the table, it's just because maybe they're not going by 1 for the x value. Don't worry too much about that. It's not going to come up on my quizzes, but next year I'm just introducing it. All right, so here's more review. We did all of that, so I'm not even going to show that. So we said when we have tables, we've got to be able to determine what the pattern is. All right, there we go. So you're going to have to figure out, one of the main things you're going to have to figure out, again, this is still the easy stuff, is what is the, what is the A and the B in the equation? You got to figure out what those are. And we said B is the pattern. Not always easy to figure out, because we don't always just give you nice round numbers like this isn't going up from 2 to 4 or 2 to 6, something where you can easily tell what you're multiplying by. So here's the formula for figuring out the pattern. I gave this to you last class, but it was a more confusing, I think, version. So this is an easier version, I think. So write this down right here. Copy the table. Make sure you make a table where you have some room in between the x and the y and the 1 and the 2. So copy all that down.
So an extra box.
You can, ideally, yes, a whole extra row, yes. If you don't, as long as you can fit in numbers above them, or in between them, that's fine. But, like, I'm not going to make an extra row. I'm just going to kind of fit them in above the 1 and 2. And it's going to get possibly a little confusing in a minute, so I'm going to do my best to explain it. If you don't understand it, like conceptually, if you just don't understand it, you can still do fine based on just making sure you're following the steps we're going to talk about when we do some examples. And once you're done writing, just kind of put your pencil down so I know you're. Are you done writing now? You copied all that down. You gotta write everything down. Everything except for the A, B, X, Y intercept, and pattern up top. You should have written that down from the page. So the table, the pattern equals bottom number divided by top number, and then Y intercept is the number when X is 0. I guess you don't have to write that if you wrote it before, but there's a reason why I put it again on the page. Yeah, we'll figure it out. Yes, actually right now is not a bad. Hurry back though, because I'm about to explain what this stuff means. Don't want to miss that. Right. Still a couple people writing. What's that? You should have already written what's at the top. The same thing we did on the page before. It's just this formula again. I pointed out which one was pattern, which one was line. I just color coded it. All right, so here's what this part means. This is how you find the pattern. First of all, if you weren't here the other day, or maybe even if you were, yeah, 2 days ago, the pattern in an exponential function is always based on multiplication. It is never based on division. Well, that's going to get confusing in a second. I need to figure out what number am I multiplying times 2 to get to 5. And you always go like, as the x values are getting bigger, you're going that direction to figure out what you're multiplying by. Now, sometimes the numbers actually get smaller over here, but you're still multiplying. You're not dividing by something. You're just multiplying by a number less than 1. You're multiplying by a fraction or a decimal. That's why the numbers are getting smaller. So it's always based on multiplication when I go from here to here. And then as I go from 1, 2, 3, 4, these are based on what am I multiplying by. Oh, that was an inverse arrow. But in order to figure out the pattern, you have to kind of do the opposite math. Kind of like when we solve an equation, and let's say we have 4x equals 8. Well, the math going on here is multiplication. That's 4 times x. But to solve for x, we do the opposite math. We divide. So a lot of times in math, you find that you do opposite math to figure something out. Well, this is one of those examples. We're going to do opposite math to figure out, and that's what this means, by the way. Top number divided by, you don't remember that, a line in between numbers means divide. So bottom number divided by top number. So if I need to figure out the pattern, I know it's based on multiplication, because I know it's an exponential function. So the way I figure out what number I'm multiplying is I just pick any 2 numbers. Doesn't even matter which 2. I pick any 2 numbers. I'll start in the middle. Those 2 numbers, and I just take the bottom number and I divide it by the top number. That gives me 2.5. So sometimes it's really easy. Like the tables we dealt with last class, it was pretty easy to just say, oh yeah, well I'm just multiplying by 2 or by 3. Until we got to the one where we were multiplying by a fraction, and then we had no idea what to do. That's why we need to understand the steps in case the numbers are a little tougher to figure out. The pattern is tougher to figure out. So I would see, here, I'm going to get rid of this real quick. Get that. Then I'll come back to it. Awesome. We're on the next step, so we can get caught up pretty quick. So if I checked any other pair of numbers, so let's say I went to these two numbers. Again, same thing. Bottom number divided by top number. I better get the same answer. If I know this is an exponential function already, I better always get the same answer when I do this. Now, if I'm just kind of testing to see whether or not it's an exponential function, I might get different answers, and that would mean it's not. There's no pattern. That's what we're about to do. So now, if I did this again, that will give you 2.5 if you do it like that. I'm not handing, actually you guys will need calculators, so we'll do calculators in a minute. I'm just gonna do the math for a minute just for you. So, that's how we figure out the number that we're multiplying. So if we took 2 and multiplied it by 2.5, we'd get 5. If we took 5 and multiplied it by 2.5, we'd get 12.5. And then 12.5 times 2.5 is 31.2. But we did have to do the opposite math to figure out what that number was over here. So just, if you got that written down, if you have that in your notes, especially on the exit ticket, this next exit ticket, I'll help. Now, if you don't have that in your notes and you got nothing, then you may be on your own. But for those of you sleeping, you might be on your own.
1, 2, 3.
Nicole's been writing stuff down, so I'm hoping she's awake.
Okay.
There you go. Almost. Let me do the next step and then you can go. So now, does everybody have that? Because I'm going to get rid of all of that.
Yeah.
Louise right. All right. So now let's talk about the y-intercept. So we want to know the y-intercept. How do we say to find the y-intercept in the table? Literally about 5 or 10 minutes. You should have just written it down when we did it a minute ago. Nobody? You didn't write it down, and that's correct. If you didn't write it down, you better be ready to write it down in a minute. Nobody knows. That's not good.
Wait, what did you say, Mr. Gill?
How do you find the y-intercept from a table? It is where x is 0.
Oh, I was right.
You find the value of y in the table when the x value is 0. So that's the y-intercept. So if you didn't write that down, you better write it. That's like the easiest question we get on the exit ticket. And if you miss those, then I know I might as well not finish even grading your exit ticket. Because if you're not getting that right, you're not going to get anything right on the next one. Oh, there we go. I skipped over one. There we go. So what's the problem in our table, though? I didn't know 0. So,
You gotta draw one.
That's why I told you to leave a space blank.
Sleepy brain.
If you do not have an x of 0, then you got to figure out what your value of y would be if x were 0. Might sound complex, it's actually not that bad. If I see the pattern in this, which I've already figured it out, I'm multiplying by 2.5, right? So times 2.5 times 2.5 times 2.5. I've already done the hard one. Now all I've got to do is just reverse that. So what am I doing if I go up? I'm subtracting 1 every time, right? So if I want to go to an x of 0, I just subtract 1, and that's going to give me an x of 0. I'm just kind of squeezing in a row. I'm making a row where x is 0. Now I just look at my y values. How am I going from 31.25 to 12.5? Am I adding? I just added something? Really? What did I add? We're not multiplying. We were multiplying when we went in the reverse order. We're dividing. It's always opposite. If you're changing the direction you're going, you're changing the map. So if I'm the number part doesn't change. Whatever I figured out is the same number. So I'm dividing by 2.5 every time I go up. 5 divided by 2.5 would be 2. So I need to take 2 and divide it by 2.5.
Isn't that 1?
2 divided by 2.5 would be 1. Because 2 divided by 2 would be 1. What did you get? 2 divided by 2.5 is what? I think it's 0.8. Is that not right?
0.8.
What we got? Yeah, that's what I thought it should be. So 0.8 would be your y-intercept. Or if you simplified it as a fraction, it'd be 4/5. So depending on how they like create the answers. On my quiz, you're going to be solving it, so I don't really care how you put it, fraction or decimal. But on a FSA or EOC next year, they're probably going to put it as a fraction. So now we've created a line where x is 0, which means our y value or y-intercept is 0.8. What's that?
Can I go to the bathroom? I think I was
Somebody was out.
I'm back. She was over.
You went, but were you asking to go? Or? All right, you can go ahead and go now. Oh no, that's what I thought. You were.
No, he was after me.
Yeah, he asked earlier.
You're supposed to be after me first.
If you want, you can go first.
Oh yeah, he was supposed to go a long time ago. Are you going to the bathroom, Lauren? I'm gonna take that. I'm gonna take that as a no. So Joe, you go, and then you're after Joe. Yeah, he asked earlier. Oh, I'm sorry. You go. You go. All right, thank you. Yeah, I forget the order, so you guys need to remember. I used to actually write it on the whiteboard, but then I'd have a list of like 15 people because they wanted their name on there. All right, now you guys do the same thing there. You need to tell me what the equation is. So I'm going to give you the format of the equation, then you just got to figure out what the letters need to be. So the letter with the X is going to be the pattern, so you got to figure out the pattern. The letter that's not with the X is going to be the y-intercept, or like the starting value. So basically, where X equals 0, what is my Y? So all you got to do is figure out the A and the B. Same thing we just did twice. And if you don't remember, you should have it written down, but to figure out the pattern, you just pick any two numbers, and the bottom number divided by the top. Yeah, I'll pass them out now while you're watching. That's a good time to do it. We don't have actual algebra calculators, unfortunately. Well, it's because you guys aren't going to take the EOC, so apparently I guess we don't have enough of them around to get to the 1A kid.
Why can't you come back like this? How are you back that fast?
Oh, no.
I use the restroom.
I feel like you just have to wherever is going.
Aaron, you can go ahead and go.
She goes first.
That's what we were just talking
How many
about.
people are going for?
Just to go after Aaron's gonna go.
Actually, after Aaron. Oh no,
So
yeah.
You don't even call me.
That's fine. I'm more worried about what you do than how you write the answer. Yeah, I think that is an algebra. I have a whole box of geometry ones which look similar to that, but they actually have different functions. You have one?
Yeah. Yeah, no.
Smarter.
You do.
If it goes the fastest.
Huh? Cause it'd be like cats? Yeah. You like cats? Honestly.
That wasn't me, that wasn't me.
You don't like our
I don't know.
Yeah.
You like cats?
Yeah.
No.
No.
They like cats.
Yeah.
Rat meat.
Sorry.
Icky.
After your way.
Ow. Mr. Gill, I'm done.
Even though you touch it. Yeah.
I'm done.
Alright. Let me get my glasses. Oh, let me see what the answers are. The answer is
Oh, I just put the wrong one in there.
Right there.
Dirty ones.
I don't know what the answer is.
Come check it.
I gotta see what the answer is.
No, you can see what. See?
That works. That works. Good. Piece of cake, right? Anybody else done? I'll check the answer.
Oh, wait, what happened?
We're doing that problem. You probably won't know how to do it. Did you say you have an answer to check? Or? Oh. That one? I got it. Right, so that's the pattern. Which number, which variable would you take out and put that number in? Like, yeah, there you go. There's that part. Right, so again, that's the pattern. So you got to take which variable is the pattern.
Well, first two.
I'm done.
No, one of those variables. There, right there. You circle it and you wrote pattern. That's the variable you take out. You still leave the x. You replace the b with that number.
Oh,
And then you got to figure out what the a number is. You got to figure out what. This will just be 0, like that. 0. You got to figure out what that is. Yeah, you got to take. I'll tell you to just do it. No, it has nothing to do with the x value. The x value is just.
No, I'm not helping you.
Perfect.
Alright, don't do me anymore. Is that right?
Can you help me?
Like 2 minutes talk to me.
This is the pattern.
yeah, her ears.
So which one does that replace? Correct. So you just put the x on it. Now you gotta figure out, okay, what would my 0 over? So you got to.
Or the other way.
No, it's not that way. It's the other way.
The other way?
And the way you test that is you can go backwards. Once you figure out what that number is, you better be able to multiply that
Just grab
number
two
by
numbers from the
1.5.
side, divide them, and
So
work.
now, if you get 1.5 times that, you better get 2.
I don't know what to
So
do.
that would be what the test is.
I had to talk to my brother, so
Oh.
but
Is that right?
Go ahead and write it in an actual like equation format, like make sure you put everything where it needs to be. So like write f of x equals some number times some number and then the rest of it. Yes, perfect. Fantastic.
No, you just said it.
So that would be, so what is it? Oh, 1.5 divided by 2 divided by 1.5. Or we're going up, we're dividing by 1.5. So that's what the pattern. Oh, yeah. What do we do? How do you go
I
from
wanna
this
get
to
one, I
that?
wanna get in
Yeah.
a big tire, just roll down.
What about that?
Or a log with my friends, I could figure out, just sit in like a seat like this and just.
That's how you got this. How do you go from this to three? No, you never throw in addition. You're doing multiplication division. No, you never.
I bet.
You don't fix multiplication division with addition and subtraction. It's either all multiplication division or it's all addition and subtraction. And anytime we're doing exponential stuff, it's always multiplication. How do I go from this? What am I doing to get from 4.5 to 3? I use the same numbers I've got. Multiplication would be going down. So we do the opposite. Right side.
Oh.
That gave you 3, right? So try 3 divided by 1.5. Do that. So guess what you do with that?
I got 1.3.
There you go.
Did I get it?
You can just put
You're
1.5.
gonna need that. Oh, alright.
No.
You got it.
Oh.
No. Oh, no.
Oh, wait, you're supposed to do like up and down.
Yeah, we would be saying this divided by that.
Oh, yeah,
So bottom divided by top. Bottom divided by top. You're doing it. Make sure you have that. Yeah, you got it written down. Bottom, just again, use your nose. Don't just try to do it from memory. No, y-intercept is that really technically the variable. Okay. So you do replacing A with that number. And then B with that.
big boy.
Was anybody waiting? Yeah, you go ahead. Oh wait, who's out?
That big dude, big fella in the corner with the red shirt.
He's not back in a minute. I'll let you go ahead.
There's 3 Aarons in this class.
Yeah, you lost your spot because you were.
Aaron.
We tried to get So that's your pattern.
What's Fernando?
So that will replace this, A or B. Good. How do you find it?
That's a
That's
dirty
How would you find A here? Like, what would you do in this case? Perfect. As long as you know that, you're gonna be fine. I don't think you've got to make another row above it. So 4, 3, 2, 1. You've got to fit in 0 in between those, and then figure out what number would go in front of that, and what number would be above 2. Don't worry about that. You're fine. If you understand how to find it from that table, if you understand how to find that, you're good. Good job.
Where's the neighbors at?
That's the pattern.
Next to your neighbor.
How do you not find the?
I see how you got it. It disturbs me. Are you supposed to write it in the equation? That's the demon.
This. Every time you're going up, if you do 6.75, divided by 1.5. You got this, right? So this divided by that gives you that. Well, this divided by that gives you that. This divided by that gives you that. So you divide it by 1.5, it's the number above. So if you divide this by 1.5. All right, so I think we're in pretty good shape.
Can you check mine?
Are you asking for a bathroom or are you? Oh, you. So this is where you got to figure out. Oh yeah, you wrote it. So 0. So what did I do to go from 6 to 4.5? Well, you're gonna use the same number. You've already figured out the number you need. Now
Yeah.
you use the number. So if I multiply this by 1.5, I'm gonna get a number bigger than that. And I would be multiplying, I'm going down. That's always the
Oh, I thought she got her.
So the pattern went up. So you would divide this by that, and you do that. This divided by that, you do that. This divided by that, you do that. Well, then this divided by that. All right, so we look pretty good on that, and that's about the hardest thing you might see on this next exit ticket. We'll do some stuff that's a little bit harder, probably next class. But today, I don't think it's going to be any harder than what you just did there. So you have the numbers right, we'll write it. So this is the pattern, right?
Gill.
This is the y value when x is 0. I want you to put it in that form. Which one replaces the a, which one replaces the b. All right, Mariah, ask me please. Thank you.
So I got all the numbers.
Did you say Mr. Gill? Oh, you said go sit down.
Mr. Gill.
Yes, sir. Why is that? I was actually talking to Joe when I said yes, sir.
Oh,
Yeah.
can you check mine?
Charger?
I got it.
No,
I'm
no
still
more
at
like
work,
that.
I'm waiting, you looked away.
Yeah, she found out.
No.
So you know why? You know why?
You would actually,
Change
you're
it.
trying to figure out what the number is that you're multiplying
No, my mom,
by.
my mom, I told
What
my mom
times 2
Huh?
gives you 3?
She told your mom about.
What times 3 gives you 4?
You know why? Because all playing on that dumbass. I see what it is.
All right, so here I'm going to pass out a sheet that you're going to work on. This is kind of our review. So for those of you that weren't here, this will be a good catch up. If you were here, it'll be a little bit review. And this is also something you can use on the quiz. So in addition to your notes you already have, this will be something that might help you out a little bit when we fill in some of the answers. This is like the easy stuff on the front page. The next page is a little bit. I'm not even having you sign out because we're only using this today. So you won't need to bring, I mean, again, I'd bring it back if you need to know the quiz, but don't bring it back. I'm not gonna be, I won't need to give you another one anyway. You are
No, because I
behind.
asked. You behind me, you just man put any.
Were you last?
Yeah.
Alright.
You better stop.
Yeah, because she's after me.
So you should be able to fill out some of this stuff. So go ahead, look it over, do what you can, and then I'll start working on it in a minute or two once I pass them all out and make sure everybody's
Yes.
okay on the problems we just finished. So for you, this will be.
Huh? Bro, why do you Captain Spell on me?
Yeah. Oh my goodness, what's on my desk? I know, I saw that.
Oh, M-O-N-K-E, and then you put M-O-N-D-Y, and M-O-N-O-K-Y.
So you should be able to do number 3 and number 4 for sure. You should be able to do well, if you were here last class, you should be able to do number 6 and number 7.
Are you just filling, are you just putting the words in there?
Yeah, on the first 8. And they're all used twice. You should be able to do sort of, well, maybe not. Yeah, I'll just explain it real quick so you can do it all.
What's that?
So look at look at the words up top. We talked about exponential and linear. Like we've talked about those. You should understand that linear means it's based on a pattern of addition. It's a straight line based on a pattern of addition. Exponential means it's based on a pattern of multiplication. It's a curved line. So if you had a graph, those of you not here last class, I told you one simple question you're going to see. If I give you a graph and there's a line on it, I might ask you, does this line represent a linear function or an exponential function? Well, if it's a straight line, it's linear. If it's a curved line, it's exponential. Simple as that. Linear is always a straight line. Exponential is always curved. So,
Mr. Gill.
well, hold on. I got to go over these real quick. We're going to do them all
What's that
together.
word?
I'm going to get to that one in a second. So we talked about exponential and linear. That's why they're not circled. Constant ratio above that. So you may want to circle it. Above it, that's the pattern. Whatever number you come up with, that's called the constant ratio. I've just been calling it pattern. The math term is constant ratio. It's the same thing as when we had this formula. F of x, by the way, is the same thing as saying y. So like when we used to say y equals mx plus b, f of x equals mx plus b is the same thing. We're just saying it's a function instead of saying y. The m value is the constant rate, because that's what we're adding every time. That's the pattern in that equation, in the linear equation. So the m was the pattern here, and we called it the constant rate before, or the rate of change. In an exponential equation, the pattern is the b variable, and that's called the constant ratio. Again, whatever variable or number is with the x, that's the constant ratio, because that's the pattern. So that's constant ratio. So now you should be able to fill out a couple more. Asymptote, I'm not super worried about it because you're going to see that more next year than you will in this class. That was this thing I showed you. One more, I think. Nope, one more. That was when we have the graph. Thank you. Actually, you can just go. When you have the graph of the line, and we said this line like starts to, the line starts to like curves. It gets close to zero, and it never crosses zero. It gets scared of zero and turns and starts going that way. The asymptote is that line that it doesn't cross. It doesn't cross this line, this x-axis. It doesn't cross that. It keeps turning as it gets closer, and it actually continues to get closer and closer and closer to it. You can't really tell that because the numbers are so small, like you can't tell the difference between them. They get so small. But this x-axis, or where y equals 0, because they're the same thing, y equals 0 at the x-axis, that's the asymptote. It's a line that the line you're graphing is approaching, but it never gets to it. It never passes it. It never even gets to it. So I'm not super worried about that. You'll see that more in algebra, though, next year for sure. So I did want to introduce it at least. So you should be able to fill in 1 through 8. You should also now be able to do 9 through 12 and really 13. So go ahead and do this whole sheet. The initial amount we said, the initial amount is the same thing as the y-intercept, wherever x is 0. So if x is 0, that y value is the initial amount, or the.
Are we just doing 1 through 8?
Now you're doing the whole sheet. You should be able to do the whole sheet now.
Oh, I'm good.
I mean, all you're doing is on 9, 10, 11, and 12 is you're just circling and underlining pretty much the number that's in the same spot every time. They didn't even change anything around.
Thank
you. Mm-hmm. Well, the whole all of today is a grade. I mean, all I do is I go back, like on a day like today, after you guys leave, I'll just take my grade book and I'll just go through and write like a class grade for everybody. You're not turning anything in really, but for anybody sleeping, not doing anything, they're pretty easy grade. For the people that I know or have been working with that team and doing every single problem, that's pretty easy grade. If you were taking a little time off in between, then you get something in between. So it depends on how much I felt like you were working. Normally they're all high grades, unless you really want to do much. So I'll give you another. I mean, it shouldn't take a real long time. I'm gonna go over it real quickly, but I don't think it's terribly difficult. So I'll walk around in a minute and just make sure everybody's doing okay on it, but don't plan on spending a whole lot of time on going over the answers. I think most people should be pretty comfortable with it. About the only one, maybe it's the last one, the multiple choice, but again, I think that's pretty good. You all done? Yes, sir. Well, we're getting the underline. Oh, actually. So it wouldn't be that actually. Because really, this is still the number with the x, even though it's a fraction. It's like that's with the x, and that's with the x, and that's with the x. Technically, that's still with the x. They put it on the outside for a reason because it's a fraction. Because they couldn't, I mean, technically they could have actually still put it in just 2. But normally when it's a fraction, they'll put the whole fraction in parentheses and then put the exponent on it. Because hold on just a second. Like if you had a fraction like this. So see the fraction up here? If I didn't put the parentheses and I just put an exponent on it, well technically that means 3 squared divided by 7. So I have to put the parentheses to show that I'm like squaring the whole fraction, not just the top part of the fraction, not just the median. So that's the only reason the parentheses are in there. That make sense?
Yeah.
I don't want to run that piece of paper.
This is mine, so I can't give you that one.
I'll give you my red
Oh, wait, here you
pencil
go.
and I'll come back and then like this is what you need. And I'll take it back. So it's like you take one thing and you take one.
Oh, did you actually have a question?
What is that?
Oh, we're getting to this next.
Okay, can you check this, please?
You could do number 5 if you want to still do number 5. We've done number 5.
Oh, I know how to
So,
do
like,
that. Can you check this? I'm on my phone. I ain't trying to carry this.
What? I can't even read this.
I got you, bro. Let me whisper.
No, you're not. These are not tables.
Just gotta cast a spell.
All you're doing is you're circling the constant ratio and then underlining the initial amount of each one. So each one of these will circle something and underline. Circle something and underline. Circle something and underline. Circle something and underline. Like that. Well, which one is the constant ratio? What's the definition? Right. So which one is the pattern based on what we learned earlier? Which variable? So you just, well, not the x, the number that's with the x. Pattern. So you just circle the number that's with the x. And then you underline the initial value, which is the same as the y-intercept. So they're all in the same place. They don't even change anything around.
It's not even finished.
I keep going up. It's not.
Yes.
Wait, who's next? I'm next, right?
Hell no.
I've been asked.
No, I asked.
He did that shit. I asked after Aaron. Yeah, you did ask.
I'll be honest, I don't remember when anybody. No.
Oh, whatever.
Like,
Yeah. Shit gotta come out.
sometimes people ask that you don't know about, so I'll be honest, I don't know what it is. Maybe we do need to start making a list.
Bro, guess what I found?
You're
I'm
getting
a special order of me in middle school has all.
Can you check this?
I'm not gonna do it.
Yes.
Okay, so you were here for this. The
Look at
pattern.
this. Look at how big this is.
Number what?
4.
You don't have that tattoo.
This is exponential. The pattern is always based on multiply. In linear, the pattern is based on add.
I knew that.
So that, again, that's different wording, but it's good still to word it differently so that you can still understand how to do it.
Oh, yeah.
You can't even read it. I could read it. I couldn't even read it.
That was the end of the clip, like, the clip was like,
You know, you like.
I got no more bullets and shit.
Maybe you're right. So this, you need to know the constant ratio is just the pattern. Like, the constant ratio is the pattern. So if the constant ratio is the pattern, we also said in the equation, right? B is the pattern, right? Well, that means that's also the constant ratio. So B is the pattern or the constant ratio.
No, stop. Stop. Don't use it.
Stop.
Yeah, bro, I don't work out.
A then is the y-intercept or the initial value. Right? So now you should be able to do certainly 9, 10, 11, and 12, but you should be able to fill in most of those too. From what we've already done.
What?
This is something I found.
Oh, it's TBIN.
What is
No,
the?
it's a
I know
Oh, you're not doing
We're
We're about to do 1 through 6 right now on our next page. All right, house C, we're gonna go ahead and move forward. I'll just really quickly tell you the answers so you can check them. Everybody looked like they were in pretty good shape on it. So the answer to number 1 was what?
Constant ratio.
Constant ratio. Answer to number 2 was what? Asymptote, if you don't know how to say it, asymptote.
Wait, what's the?
1 was constant ratio. You should be able to get that one on your own.
I had that.
Number 3. If it's based on addition, what kind of function is it? Linear. If it's based on multiplication, what kind of function is it? I'm on number 4. If it's based on multiplying, what kind of function is it? Exponential. Number 5. What is the line y equals 0 in that? If you didn't know what they meant, it's not a big deal on that one, but it's an asymptote. Number 6. What? There's a lot of people I'm having to talk over, so I should hear that. So number 6, in that particular equation, is that a exponential function or a linear function? It's exponential. Anytime you see an exponent, even if it's a variable, it's exponential. Now look at the next one. Do you see any exponents in that?
No.
Then it's linear. And then last, in the function y equals 5x, 5 is the what? What else is it? The pattern. So I wrote this up there. Probably not a bad idea to write them both in the same spots. So I'll write it for this one too.
Is that baby shark?
Y-intercept or initial value.
I saw it. It's a baby shark.
Or initial value. So same formula we had before. F of x would be there, I guess. A is the y-intercept or the initial value. You'll hear it called both, I guess. B is the pattern or the constant ratio. So if you want to add that into any notes that you had. So for 9 through 10, they didn't even change anything around in 9 through 10. The number on the right, so 1/2, 1.5, 2, and then whatever's below that, those are all what? Yeah, they're the patterns or the constant ratios. They're the B value. All the numbers on the left are the initial amount or y-intercept. All right, let's go to the next sheet because that's where it actually gets a little difficult.
Was number 13 B?
I believe it was. I don't remember pictures, but yeah, sounds like it was. So now this is getting into more complex stuff. All of that stuff is easy. Better get 100% on everything we've done so far. Now it's going to get a little tricky. We need to graph some of these, which we struggled on graphing in the linear stuff, so we'll see how we do on this. It's not going to be a perfect graph. Not going to be a perfect graph because of the curving of the line. It's not, the pattern is a little more difficult to draw. So just, you can kind of just wind up doing your best on it. But the points you put on the graph is mainly what I'm going to grade, or the points really that you put on your table. So here's what you would do. Tell you what, I'm going to do the ones that I have here. These are more difficult, but if you follow along with these, then you'll be fine on the other one. Oh, here. All right, so here's the one. This is not on your sheet. I'm just using this as an example. There. So if I have that function, all right, that is an exponential function. I know it's exponential because it's an exponent. And I'm multiplying times a pattern, and I have an initial value. I need to graph that. Unlike doing a linear equation where sometimes you can do like a y-intercept, rise and run thing, there's really no way to graph these besides just creating a table and coming up with some points to put on the graph and then drawing a line through the points. So we're going back to old school. So you will do these same steps. So you don't have to graph this one because the numbers get really big, but you want to write this note. In order to graph an exponential function, you have to create a table of values, I guess you said. And I'm going to do it for you so you'll understand hopefully what that means. But the less you understand it, the more notes you better be writing as I'm going through and doing it. Again, you're not going to actually be graphing this one because you don't have any graph paper that goes up to 20 and out to 7. But you mainly just need to take some steps on what I'm doing so that you can repeat it in a minute. So you will need negative x values. So make that note. You will need some negative x values. You're really going to use the same x values every time. You're not going to really ever use different x values. So you'll start at -2 and typically go up through 3 would normally be enough. And you won't even use all of those when you plot them on the graph sometimes. So you'll pretty much always use those -2 through 3. The reason is their x values get really high. Like you start getting into 4, 5, 6, or even -4, then the numbers over here start getting really, really big. Because remember, we're doing exponents. So we're basically, the x is going to be the exponent. So now you're going to start multiplying something times itself 4 times, and you get into really big numbers. So that's why you're not going to use that many x values. I always start with 0. My first value is, or my first y value is always 0. So write that down. The first y value you're going to solve for is where x equals 0. Well, no, the first y value is not 0. The first y value is where x equals 0. That's the first one you solve for. Why would that be the first one I solve for? Why wouldn't I start at the top of the table like we do most of the
easiest number.
Yeah, make my math easy. I'm all about easy math, so I'm going to make my math easy. And if this is my equation, I'm going to write, here, I can write the equation right here because I'll just erase it. So the equation is this, and I'm just getting it from right here. 4 times 2 to the x power. That's the equation. Well, if x is 0, if I'm solving for this spot right here, I just plug in 0 for x. That's all I do. So that becomes 4 times 2 to the 0 power. Oh, by the way, we did not do well on this part of the quiz. Although I haven't graded you guys, man, you did better.
Let's get rid of work.
What I know, it's funny, you guys were, well, you weren't the first class to take it, you were technically you were the third, but you're the last class to get through. So, what is 2 to the 0 power? Oh, you have to do the exponent piece first. Remember, order of operations. Exponents comes before multiplication. So I'm doing this first, then I'll come back and multiply by 4. Don't do 4 times 2. So you may want to make that note. Make sure you do the exponent part first. The exponent math, or whatever you want to write. It's guaranteed somebody's going to do left to right 4 times 2 and then try to raise it to an exponent. 0. So 2 to 0 is what? There we go. 2 to the 0 is 4. You went up. You're just guessing numbers.
17.
2 to the 0 is 1. Anything to the 0 power is 1. That's why I choose 0, because then I don't have to do any math. I just know it's 1. So then I multiply times 4. So my y value is 4. So that became 4. And again, I haven't solved for anything else. That was just doing the problem. So now let's do the next one. I'm going to use 1. Again, why did I choose 1? Mr. Gill, why did you choose 1? Well, because it makes my math easier normally. So now, I guess I could do it over here on this guy. So 4 times 2, but now I'm raising it to the first power. That's a 1. Yeah, I didn't know if it was showing up real well, so I made it a fat one. What is 2 to the first power? Say it, 2? Oh. 2 to the first power is 2. All right, well, if 2 to the first power is 2, then I do the multiplication next. So when x is 1, I solved it out and I got a y of 8. Follow that one. Sure looking confused. So now here's what's going to happen. Eventually I'm going to get into the negative numbers and then the math starts to get a little tougher. Or I'm going to get into these numbers and the math starts to get a little tougher when I'm squaring and cubing and doing all of that. But guess what? You don't have to do any more math with that equation if you don't want to. Why is that? Who knows why? Why don't I have to do any more math with the equation? Yeah, but I got a whole bunch of things I still got to do. I got to complete that table. Why don't I have to plug in -1 and then do this and times 4, or -2 and then do this and times 4, or 2 or 3 and then times 4? Why don't I have to do that?
Are you recording the lesson?
I am. Why don't I have to do that? What's true about an exponential function? How do we know it's an exponential function?
We have our
It
own
has
little
an
thing.
exponent.
It's got an exponent, but what if I have a table and I don't have an equation?
What you multiply by?
So what did we call that? We said there was a what? Starts with a P.
Pattern.
Pattern, right? I know the pattern's based on what math?
Multiplication.
So what did I multiply times 4 to get 8?
2.
Then I'm just going to keep multiplying by 2. I don't have to go back to that equation. If I know this is an exponential function, which I do, it's telling me in the problem up there, this is an exponential function, then I know my pattern is based on multiplication as I go down. I don't have to deal with these negative x's or these bigger x's up there. I just focus on the pattern. Now, if I need to go up, what am I doing to go up? What did I do with 32?
Divide by 2.
And you can say division when you're going up. That's fine to say division going up. Just don't say you're dividing when you're going down. So if I'm dividing by 2, well, 4 divided by 2 is 2. 2 divided by 2 is 1. That's a whole lot easier than plugging those numbers in over and over again into this and then multiplying out. So just do the first 2, hit 0 and 1, because normally that's easier. and then get your table. Now you have to graph it though. So you're not going to use every number because sometimes they get really, really big or really, really small. But 0 and 4 I would definitely put on there. So there's 1. 1 and 8 for this graph will fit on there. -1 and 2 I would also put on there. -2 and 1 would be there. If I did -3, it would be there. And then these will kind of keep going. And 2 and 16 will fit on there. So there are my points. You can see that it starts to curve. It's actually really steep. So something like that. So there's your process for graphing from an equation. So you should now be able to do number 1 and number 2. Again, if it's a fraction, just take 0 and 1, figure out what the pattern is, and then use the pattern. Don't try to do all. Now you still need to do all the other values. So even though it's a fraction on number 2, 1/4, if you pick 0 and 1, you should be, I think, able to figure it out. I'll help you with the math on that one a little bit. And you should be able to do number 5 also. So 1, 2, and 5 is what you're working on right now.
Wait, what?
This is on the second page of your little packet from today. 1, 2, and 5.
Plus.
I will put up an example of a fraction one while you guys are working. Don't waste time. I mean, I'm going to walk around and make sure you're working. So you're going to get a grade. Oh, wait. Whoa. I frankly don't remember when he asked how long I held him for.
I would have went.
See, I don't know.
All right, get to work. I'm walking around in about 2 minutes, so you better be working. Most of you have been doing a pretty good job. Some of you could use a couple extra points. Some of you shouldn't be on your phone. No, none of you should. But most of you are not. So let's see. Yeah, no excuse. Again, you guys can say, well, I was just. As soon as you start saying I was just, tune you out. There's no reason that there's no I just. All right, so that makes it pretty easy. 0 is just going to make it 4. And 1/2 is just going to make it 2. 1. 1/2. 8. 16. So there's an example of a fraction right there. I'm not going to graph the points out. You should be able to do that. Oh, actually, here. All I did was these two right here. I just did those two, and then I figured out what the pattern was from the fact that I must be multiplying by 0.5 if my number is getting smaller. And I just kept doing that all the way down, and then I did the opposite way up.
Oh my God.
Only they were extreme.
Well then go do the other one. All right, that one looks like. You need to know how to graph. We've done that before. I'm more concerned about you graphing. I'm more concerned about you being able to do the graphs than I am that table. We did tables last time. So do the graphs. Mariah, have a seat. Work. All All right, let's see how we're doing. Again, you start with the table before you jump in the graph. You gotta do the table. I told you what values to use. It's always gonna be the same x values. You just gotta plug in those x values as the exponent, and then do the math on a couple of them. The x values will always be the same. But then the y values will be mean. That's the ones that are different. Now you are going to want to do a couple of negatives, like I said.
So you go like this, Mr. Gill, blah, 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 blah.
This will always be the same in your table.
Now what do I do?
Anything I create, that column will be the same. You're going to use the same x value. Then I always plug in these two. So I plug in this and solve for that y, and this and solve for that y. I plug in 0 and 1 for x first. Then I don't do any more math with the equation. I just figure out what the pattern is, and I do the pattern all the way down and the pattern up. If you want to keep plugging it into the equation over and over again, you can do that. So set it. You got set a table. Oh, I didn't mention this. So set a table up. When you're graphing these, you're going to have to create the x and the y axis. You'll see they didn't create it for you. You're going to want to create the x axis down here. Then you can do the y in the middle. That's fine. So do it like that. And you're going to probably have to, like count by numbers greater than 1. Because you're going to get some pretty high numbers in your final answer. But if you just mainly fill out the table, that's what I'm really concerned about. You'll be able to, I'm hoping you'll be able to put the points on a graph when you get to that point, and I'll give you a graph that matches with whatever table you should be creating. So just make sure you create the table. That's the main thing. So put some x, y values in. So 0, now if it's 0 though, it's 3 to the 0. 3 to the 0. 3 raised to the 0 power. 1. There's nothing, it's not 3 times something, it's just 3 to 0. Well, but it's again 3 to the 0 is not 3. 3 to the 0 is 1. There's nothing like here you go. Problem solving. That's why I'm getting a number. There's no number time. All right, then. I'll assume you guys did nothing.
No, I did something.
Yeah. You want me to give you any credit? So again, this is why I'm making sure I check. Now all we're doing is raising the number to a power. This is not 3 times. This is 3 to the 0. So I'm replacing x with 0. 3 to 0 is 1. The reason we kept getting numbers is because we had a number in front. Like in this one. Here you have 8 times something. So when x is 0 in that one, it will get 8. Because you're saying 8 times 1. But everybody's done what you did so far, which is why I'm still walking around.
Yeah, I'm gonna destroy that.
Yeah.
Yeah, I'm gonna destroy that.
Everybody got you guys have any football that you're doing at all now? Or, I know this teams tournaments or spring or like what's it called? AAU for basketball. Like what you did before you had this.
Oh, she just waits for her friend.
I wasn't mad.
Good afternoon, faculty and students. Just want to take a few minutes to thank our administrative professionals for all that they do each and every day to make sure that
Where are you Monday?
supporting students and
You really just skipped school?
I was sick.
You think you were sick?
and we recognize
You were sick of coming to school?
My head hurted really, really bad. I can't wake up, so I just.
all of your afternoon announcements. Have a great Patriots Day.
All right, you guys have a good evening. Quit or exit ticket on Friday. For you. Well, I gotta do attendance. I gotta do attendance. Where's my? Oh, right there. Duh. So seems like you're fine with that, both you guys, right? Did you try to do the table?
What table?
Like when I told you you had done that one, but then I said try to at least show me the table. Did you do it?
One number on the table for the line.
Like
And it
did
was
you?
3 on the 0. So I don't think I got it.
Yeah, it's not a 3. That's why I wanted to check because a lot of people do that. If you're replacing x with 0, this is just 1. The only reason we kept getting numbers there is because there was a number in front. So like if you make that a 0, this becomes 1, but then you're multiplying that 1 times 8. We don't have anything in front of this that we're multiplying by. There's no, like they're not showing an a value. So here's the question. If there's no a value, what is the a value?
0.
Not 0.
I don't know.
Yeah, we'll go over that next class. Right before we probably have the exit ticket on it. So I got to do attendance. Who's that?
My peanuts, bro.
I didn't bring cash.
Oh, I got to stop the recording.
Mr. Gill, you got my report card? Yep.
Your report card? No.
Mr. Gill,
That's
all these
fifth
blue
period.
papers.
You got to go to your 5th period class.
Oh, my 5th period?
Yeah.